Hi, fifth graders. This video is all about finding common denominators and equivalent fractions. And this idea is super important to everything that we do within our fractions units. So let's take a step back and refresh our memory on some earlier concepts. The first is that we know that the denominator of a fraction represents the size of the piece. So for example, in the fraction 1/4, the denominator of 4 tells me that my whole is split up into 4 equal-sized pieces. Now we've also learned that the denominator of a fraction is the unit we're working with. And that's kind of different because we don't usually see units that are numbers, but it's important to remember that when we are talking about a denominator of 4, we're talking about a unit of a 1/4 sized piece. So why is that important? Well, in order to add or subtract fractions, we need to be adding or subtracting the same unit. That means we might need to find a common denominator and rewrite our fraction in order to add or subtract. So you might be wondering, well, how do we find a common denominator? In order to do that, we need to list out the multiples of both of our denominators until we find one that's on both lists. This is going to be a common denominator that we can use. So let's take a look at how we can make this work with an example. So again, common denominators are going to allow us to rename or rewrite fractions so that they have a common unit. So for example, let's say we had the fractions 2/3 and 1/4. I see a denominator of 3 and a denominator of 4. I can model that using fraction tiles by 2 1/3 sized pieces and 1 1/4 sized piece. So first, I need to list out the multiples of both of those denominators until I find one that's on both lists. So that will become my common denominator. So my multiples of 3 are 3, 6, 9, 12, 15. I could keep going, but I usually recommend to fifth graders to stop after you get to the first 5 multiples. Usually you'll find a common denominator within the first 5. Now, if I list out the multiples of 4, I have 4, 8, 12, 16, and 20. Since the number 12 appears on both lists, I know 12 is my least common denominator. And it's the least one because it is the smallest possible value we could have for these two numbers in common. And basically what that means is I can rewrite my 2/3 and my 1/4 using 12th size pieces. So I would cover up the thirds and the 1/4 using those pink 1/12 tiles, and it would line up perfectly. Now this helps us because it's how we're going to make equivalent fractions. So remember, we use common denominators to make equivalent fractions because we need to add and subtract with a common unit. So these two models show different examples of equivalent fractions because the same amount is shaded in each rectangle, whether they're more square like the larger model on the left, or they're more like our fraction tiles in the smaller model on the right. Either way, the fractions are equivalent because the same amount is shaded in each of those rectangles. So let's take a look at that example 2/3 and 1/4 again. This time I'm only going to model one of the 1/3 pieces and the 1/4, but we'll show you on paper how this works in a second. So first, when we're making equivalent fractions, we have to find that common denominator. We know that meant we would list out the multiples of both our denominators, and we found in the last step that a common denominator between 3 and 4 would be 12. So then our next step to make equivalent fractions would be to use multiplication or division to adjust the numerators of our fractions. So what do I mean by that? Let's take a look at the 2/3 first. If I have the fraction 2/3, I know that I'm turning it into an equivalent fraction out of 12ths pieces. So when I'm looking at that, I know that I have one relationship I know. The denominator has changed from a 3 to a 12. And I have one relationship that's a mystery. The numerator started as a 2, but it's going to end as something different because when I'm using 12ths pieces now, I'm going to have more pieces since they were sliced into smaller sections. So I'll use multiplication to show the relationship. Since I know that 3 times 4 is 12, I can also multiply my numerator of 2 by 4. So that tells me that 2/3 is exactly the same as 8/12 pieces. And if I look at my 1/3, I knew 1/3 could be covered up with exactly 4/12, so it makes sense then that 2/3 would be covered up by 8/12. Next, I'll look at my 1/4. Again, I want to turn this into an equivalent fraction made out of 12ths tiles. The relationship I know is the denominator. So in order to turn 4 into 12, I had to multiply by 3. So since I multiplied my denominator by 3, I also need to multiply my numerator by 3, which tells me that 1/4 is exactly the same as 3/12. I can show that with my fraction tiles because if I lined up 3/12 tiles on top of the yellow 1/4, it would be exactly the same size. Let's take a look at a couple more examples together on paper so that we can really make this idea stick. All right, so let's take a look at combining this idea of finding a common denominator and making equivalent fractions. And most often, you probably remember you need to do this when you are adding or subtracting fractions. So a lot of times you'll be given a set of fractions. I want to point out that if you're only given one fraction, for example, if I only asked you to make equivalent fractions for 4/5, you could make an infinite number of possibilities. And that's true also with 4/5 and 1/3, but the number of possibilities to start with is a little bit more defined. So first, in order to make equivalent fractions, I need to find a common denominator. So that means I'm going to list out my multiples of my denominators 5 and 3. I always recommend starting with the first 5 multiples because most of the time you'll find something in common in the first 5. So my first 5 multiples of 5 are 5, 10, 15, 20, and 25. And my first 5 multiples of 3 are 3, 6, 9, 12, and 15. I recognize that on that list, both share 15 as a common multiple. So that means my common denominator for these two numbers is going to be 15. So now when I change 4/5 into an equivalent fraction, I need to figure out this denominator relationship is the relationship I know. So since I'm using multiplication, I need to think 5 times what is 15? I can also check my list here to see that it was the third multiple. That means I multiplied 5 times 3 to get 15. So I need to do the same thing to my numerator because what I'm really doing with my denominator is I'm taking each of these green 1/5 pieces and I'm slicing them into 3 pieces each. That's what's turning this into 15 little slivers. So if I did that with my 1/5 piece, I also need to do that with my 1/4 piece. I need to slice these into 3 slivers. So to show that I did that, I also multiply my numerator by 3. 4 times 3 is 12, so 12/15 is exactly the same as 4/5. Now with 1/3, 15 was the 5th multiple. I took those thirds pieces and sliced them into 5 slices. So I also need to do the same with my numerator of 1, which tells me 1/3 is equal to 5/15. So my equivalent fractions are 12/15 and 5/15. Let's take a look at 5/12 and 3/4. So again, I'm going to start by listing out my multiples, 12 and 4. The first 5 multiples are 12, 24, 36, 48, and 60. And the first 5 multiples of 4 are 4, 8, 12, 16, and 20. Now on this particular list, I have 12 in common. That means my common denominator is going to be a 12. In this particular case, I don't have to change my first fraction at all. This is like saying times 1 times 1. So 5/12 remains exactly the same. But 3/4 does need to change into 12ths pieces. I know that 12 is the third multiple of 4. In other words, I multiplied 4 times 3 to get 12. So I also need to multiply 3 times 3 to show that they are in common or equivalent. So that gives me 9/12. So let's take a look at that a little bit more closely. So if I had 3/4, I want to prove to you that we multiply the numerator and the denominator by the same number for a reason. So I had 3/4 to start. And what I did was I turned those fourths pieces into tiny little 12ths slivers. So what I did when I multiplied by 3 was I said that for every 1/4 piece, that meant there were 3 1/12 pieces. So if I had 3 full 1/4 pieces, I needed to multiply each of those by 3, which tells me that my equivalent fraction is 9/12. And as you can see from lining up these pink pieces, those 3 yellow 1/4 tiles line up perfectly with 1, 2, 3, 4, 5, 6, 7, 8, 9 pink 1/12 tiles. Let's take a look at one final example. This time I have 2/5 and 5/6. So again, list out my first 5 multiples of 5 and 6. So 5, 10, 15, 20, 25, and 6, 12, 18, 24, 30. Okay, so remember how I said most of the time the first 5 multiples will work? In this particular example, the first 5 multiples don't share anything in common. When you don't share anything in common, that doesn't mean that you're done. It means you need to try a couple more multiples. I always suggest starting with your lower number and trying a multiple at a time. And if you watch what happens here, by going up just one more multiple of 5, I end up with a common multiple. So most of the time, you will be able to make this work with 5 multiples. But if 5 multiples don't have any matches, that doesn't mean you're done. Keep extending those lists. Now, in order to turn 2/5 into 30ths pieces, I know that 30 was the 6th multiple of 5, so I multiplied by 6. 2 times 6 is 12, so that tells me 2/5 is equivalent to 12/30ths. And to turn 6 pieces into 30ths, that was the 5th multiple. So I multiply by 5. 5 times 5 is 25. So that means 5/6 is equivalent to 25/30ths. So be on the lookout for needing to extend your patterns, for questions where you can keep one fraction the same, and for questions where you need to change both of your denominators. Thanks for watching, and I hope this helped refresh your memory.